All right, so for today, there are 10 objects or 10 equations off to the left-hand side. We're going to play tic-tac-toe. You're going to fill in the 9 spaces, one from each list below. Use one per space. We'll use 9 of the 10, so there'll be one we won't use. I'm going to start with this first one here and just label it, let's see, 12 minus 4x. That's the first one. And then the next one, 8x plus 4 minus 12x. I'm going to put here 8x plus 4 minus 12x. Next one, 8 parentheses, 1 half x minus 2. I'll put here 8 parentheses, 1 half x minus 2, close parentheses. 12 minus 6x plus 2x. I'll put here 12 minus 6x plus 2x. And what do we got? Negative 4x plus 4. Put there. X minus 2 plus 2x minus 4. It's a long one. I'm going to put over here. X minus 2 plus 2x minus 4. 4x minus 12. Sure. And 4 parentheses x minus 4. And 3 parentheses x minus 2. And we did not use this bottom one here. And so now what I'm going to do is I'm going to go ahead and I'm going to throw up an equation, and we're going to see which ones are equivalent, and any that are, we're going to mark with an X and see if we made a tic-tac-toe pattern anywhere. So we're going to go ahead and say that it's 4x minus 16, and anything that is equivalent to that, we're going to mark with an X. Anything that's not, we'll leave. So 3 parentheses x minus 2, the way we'd do this is we would distribute, so 3 times x and 3 times negative 2. 3 times x is 3x, and 3 times negative 2 is negative 6, so I have 3x minus 6. That does not match, so I'm not putting an x. We distribute here, so I have 4x, and then minus 4 times 4, so I'd get 4x, and 4 times negative 4 is negative 16. That does match this guy here, so I'm going to go ahead and I'm going to do, instead of an x, I'm going to do a star just so we can clearly see it since we have x's, right? X's and o's. So I'm going to do a star. Cool, so we got a star there. 8x plus 4 minus 12x. Well, we're going to combine the minus 12x and the positive 8x. If I owe 12 and I have 8, I'll still owe them 4, so there's minus 4x. And we always want to put the x's in front, right, of our numbers, and then this number is back here plus 4. We can't combine that with something else, so it's negative 4x plus 4. That does not match my 4x minus 16, so I'm not putting a star there. Here I have 12 minus 4x, and so we want to put it again in front order. We want x's in front, so I've got negative 4x rewritten, negative 4x. I'm just taking this and moving it up to the front. Negative 4x, because it's minus in front, right? So negative 4x, and then this 12 is positive, so it'd be negative 4x plus 12. That does not match this one up top, so we're not going to go ahead and mark it. Here we would distribute 8 times 1 half, or what's half of 8? Half of 8 is 4, so I've got 4x. And then 8 times negative 2. 8 times 2 is 16, so 8 times negative 2 would be negative 16. Hey, that one does match there, so I'm going to go ahead and throw a star in. I did randomly stick them in here. I kind of fit it more or less just where some of the larger ones were off to this side on purpose, because then I could kind of write offwards. Anything that was smaller, I kind of put more towards the middle. 4x minus 12, well, that one definitely doesn't match. And there's nothing else we can do, right? We can't combine the x's with the numbers, so 4x minus 12 would stay 4x minus 12. Nothing would change there. Bottom row left here I have 12 minus 6x plus 2x, so I'm going to combine the negative 6 and the positive 2. Negative 6 and positive 2 is negative 4. We want to put the x's in front, so I have negative 4x plus 12. So again, same thing actually. If you look, these two here, this one and this one, are equivalent, right? They're worth the total same amount of stuff. This one in the bottom middle is actually already, I'm just going to rewrite it up top, but it's already written in perfect form. There's nothing we could reduce, and the x's are already in front. So I'm just going to rewrite it, and that does not match. And the last one here says we're going to combine our x with our positive 2x. X and 2x is 3x's total. and then I've got a -2 and a -4 for a total of -6. That does not match either. We did not get a tic-tac-toe this time, and that's okay. It wasn't, wasn't a requirement, but I wanted to go through everything to make sure we're all clear on this, and made sure we knew how to do stuff. So again, this was a combine like terms, and we are specifically looking for equivalent expressions. So equivalent expressions with the rational numbers. Here we're looking at this, so we're starting with all of our prices off here to the left hand side, and then looking at discounted amounts. This says 20% off. So how would we write this? We would write this as 20% off of 80, right? Or excuse me, 20% off of 100. So we would convert this to a decimal. 20% as a decimal is 0.20, right? We'd multiply it by our total, or our original, of 100. And so this would be 0.2 or 0.20 times 100 would be, if we're saying these are in dollars, this would be $100, right? Or 100 times 0.2 should be $80 here. Sorry, I wrote $180 here. Okay? And why did I say 80? I must have been looking on the other side. I'm sorry about that. 0.2 times 100. 0.2 times 100, Harry, do you need more coffee, is $20. The new price, we would take the 80%, turn that to a decimal, so 0.8. Remember, when we turn something to a decimal, when we sing the alphabet, right, A, B, C, D, so A, B, C, D, and then E, F, G, H, I, J, K, L, M, N, O, P. So we have decimal and percent, right? So we're always moving it 2 spaces. If we go from a decimal to a percent, do we see how we would go in the alphabet? We would go to the right. So we would move it 2 spaces right. Do we see how if we go from percent to decimal? P percent. P comes after D decimal in the alphabet. That means we'd actually need to move it 2 spaces to the left. We always move it 2 spaces. And so left or right, as long as you know your alphabet, you know which direction to move the decimal. All right? So 0.8 or 0.80, 0.80 times 100, and that is $80, right? And so our expression here would be 100 times 100, our original price, minus 20, our discount amount, would give me 80, the new price to pay. Okay. Same thing is true here with the 50. So you notice all of these are 20% off. So I'm going to go ahead and do all of these real quickly. 0.2, 0.2, 0.2. And now all we're doing is we're filling in these additional pieces. So 0.2 times 50, 20% of 50, 0.2 times 50 is 10. 0.2 times 28 is 2.8 and 2.8. Sorry, doing some mental math here. 2 and 2 is 4.8, and 0.8 is should be 5.6, so $5.60. 0.2 times $14.50. This is going to get a little more tricky. I'm going to grab my calculator quickly, but I believe it should be 290, if memory serves right. 14.5 times 0.2. Yep, 290. Just double checking. Never hurts to check on a calculator, and that's why we have it in class. $2.90 to be exact, not $290. $2.90 would be the 20% discount. And then I have the same thing here, but it's just going to be multiplied by, instead of a number, it's a letter, it's X. That's okay, because later on maybe it really is $14.50. We already have it, right? So we can then take that, whatever it is, and plug it in, or the mathy term is substitute for the X, and come up with that amount. So in this case, it would be 0.2X. 0.2x. Looking at the next set, we have the same stuff. So again, it's going to be 0.8 for all of them. 0.8. And you could say 0.8e, but 0.8, it's less work and it means the same thing because there's a bunch of zeros behind it, right? So times each one of our pieces here. So times x times 1450 times 28 and times 50. 0.8 times 50 is $40. That's a 4, not a 9. Sorry. 40. 0.8 times 28. Got my calculator right next to me. Is 22.4. Or $22.40, since we're talking money now. We got 0.8 times $14.50. It's $11.60. And 0.8 times x is 0.8x. Don't overthink it. The expression for each of these is going to be my starting, so I've got 50 here, minus my discount, in this case it's 10, should equal my new price to pay. 50 minus 10 is 40. 28 minus $5.60, or 5.6, should be 22.40. 1450 minus 290 should be 1160. And my last one here, I should have x minus 0.2x equals 0.8x. And quick reminder, we don't see a number in front of x. There's an imaginary, it's a terrible line there, but there's an imaginary 1. I like to do this in class. So you see it's like a imaginary, right, or a dashed 1. So there's an imaginary 1 right here. You don't have to write it, because if I say I have a hat, I have 1 hat. If I have a pen, I have 1 pen. If I have an apple, I have 1 apple. If I have an X, I have 1 X. If I have anything other than 1, I have to disclose or tell you how much that is. But if I only have 1, I don't have to say the number 1. I can just say a or an. Okay? So, item that has an original price of X dollars is discounted 33%. We're going to write the expression that represents the amount of the discount. Well, the discount would be my discount percent, so 33%, changed to a decimal. Hang on, I'm busy. Hang on, I'm busy, buddy. Converting a percent to a decimal. So we're going to convert 33% to a decimal. And then from there, we can take that decimal and multiply it by our original amount. In this case, it's x. So 33% to a decimal would be going from percent to decimal. We move it 2 spaces to the left. So this would be 0.33 as a decimal. We're going to take that and multiply it by X dollars, since we don't know what that is. And writing the expression, it would be 0.33 times X, or 0.33X. Write 2 equivalent expressions that represent the new discounted price. We can write this as our original minus 0.33X, and that represents the new discounted price. We can also take the original and do the subtraction of it, 0. So that's our first expression. Our second expression would be taking x minus that, or remember again, there's an invisible 1 in front of it, right? So 1x minus 0.33 repeating. And 1 minus 0.33 repeating is 0.67x. We can use one of our expressions to calculate the new discounted price if the original price was $56. What we're going to do is take that 56 and plug it in to anywhere we see an x. Now, the faster one to do would be the bottom one. It doesn't really matter. So let's go ahead and do the bottom one for that, and we can use the top one to then confirm it later if we want to. So 0.67 times $56, and I put it in parentheses, and the way you're supposed to do that is put that in parentheses so that anybody who follows your work knows that that's the number you substituted or plugged in. And I get the new discounted price of $37.52. How would the expression you create in parts A and B change if the item's price had increased by 33% instead of decreased? Well, in this case, if it increases instead of decreases, subtraction means decrease, so add would mean increase. So this would become, for instance, the number one, the top thing would stay the same as far as going it to a decimal amount, right? But instead of 0.3% or 0.33x as the amount of the discount, that would be a markup, which means we'd add. So the first number, A would stay the same, B would simply be x. Instead of minus, it'd be plus 0.33x. And we'd end up with our second answer, which would also be the second number, which would also be the answer to that, which would be 1.33x. 1 plus 0.33 is 1.33. And last one here for our classwork, we're looking at how we change stuff. So this is all the same stuff that we did from our very beginning. We're now looking at the new price. So using the new price, right, we have the expression here. Our new price would be $80. Would be, where is this? Oh, sorry, $40 would be $22.40. Would be $11.60, and would be 0.2, my 1 minus 0.2 or 0.80x, right? And now we have a sales tax of 8%, so we're looking at having an additional price of 8% as a decimal is 0.08. So we're going to take each one of these pieces here, multiply it by 0.08, and then we'll add that into the overall cost. So 80 times 0.08 is 6.4. Oops. 40 times 0.08 is 3.2. $22.40 times 0.08 is $1.79 and then 2/10 of a cent. So we only use two decimals for math with money. So 1.79. There was a 2 after that, so we don't round. 1160 times 0.08 is 0.928. 0.928. And since this is a 2 and then an 8, it rounds to a 93. And then I've got 0.8 times 0.08 is 0.06 and then a 4, so it rounds down, so 0.06 additional x's. Then the overall cost, all we're going to do is we're going to add these two things together, and it's going to equal my overall cost. And we're not going to rewrite this expression down here only because we'll have done it leading up to these other pieces here. So 80 times 6.4 is 86.4. 40 times 40 plus 3.2, excuse me. 40 plus 3.2 is 43.2. 22.40 plus $1.79 is $24.19. So 24.19. 1160 plus 0.93 or 93 cents is $12.53. $12.53. And the last one is going to be 0.8 plus 0.06 is going to be 0.86, and then it's an x because these are all x's. X here, right? Okay. And we are off to problem set.